Dear students, let's see this question which is given in GW Advanced 2021 question. Just we'll see. Here, in order to measure the internal resistance R1 of a cell EMF E, a meter bridge of wire resistance R0 is equal to 50 ohm, a resistance R0 by 2, another cell of EMF E by 2, internal resistance R, and a galvanometer G are used in a circuit as shown in figure. If the null point is found at L is equal to 72 centimeter, then the value of R1 is. So here in this circuit, what he is given is, if you observe in this circuit, we are going to calculate the value of R1, and what is saying, the meter bridge wire resistance is 50 ohm. That means from A to B, this wire offering how much resistance? 50 ohm, and resistance is R0 by 2. This resistance is given as R0 by 2 is given, and here it is E and E by 2 is given. And one more point, if you observe, the galvanometer G is showing null point at 72 centimeters. So here galvanometer is showing null deflection, zero deflections. What is the meaning? Bridge is said to be balanced. When bridge is said to be balanced, under balanced condition, no flow of current through the junction, through the wire, and at that point we can use E by Q is equal to R by S, or we can apply the loop rules also. Just see here. First we will try to understand how much resistance is here, how much resistance is offering. So here it is given that the total resistance across A and B is 50 ohm, and bridge is balanced at 72 ohm. So we will write for 100 centimeter length, 50 ohm resistance is given, and for 72 centimeter length, how much resistance will be there? So R 72 centimeter length can be written as 72 into 50 by 100. So 50 2s are 236 are. So R 72 is equal to 36 ohms. That means the total resistance is 50 ohm. Up to 76 centimeter, 36 ohm is offering. So it will be 40. And total resistance R0 is 50. So this one is R0 by 2. I will modify this one as 25. So if you observe this modified circuit, we can write modified circuit. How we can modify? Here this is E and this is R1, and here E by 2, and this is R, and in between these two the resistance is 36 ohm, resistance is 36 ohm, and again here 25, and here the resistance is 14 ohm. Again we can modify the circuit. We will see how we can modify. This is E1, so this one is E, and this one is R1, what we are going to calculate, and this one is E by 2, and this resistance is R, and this is 36 ohms. See here, these two resistors are connected in series. In series formula, R1 is equal to R2. In series formula, R is equal to R1 plus R2. In this situation, 25 plus 14 can be written as 39. So here I will write 39 ohms. So now our target is to find the value of R1. In order to find the value of R1, I am going to apply KVL rule. One thing we have to keep in mind, that here the bridge is balanced condition. Under balanced condition, across A and B, there is no flow of current. That means the total current in the junction AB is 0. Let us assume in this loop I am saying that this is I1, and in this loop I am considering this is I2. Then if you see across A and B, this I1 is moving up and I2 is coming down. Clear? The total current will be 0. So what he is given? So we know as bridge is balanced current across AB is equal to 0. Current across AB is equal to 0, which means current across AB can be written as I1 minus I2 or I2 minus I1, the difference can be written as 0. I will write I1 is equal to I2, let I say. Why? Because here I1 is equal to I2, just I am considering it will be I. Then just to apply here, apply KVL. Apply KVL for loop 1. In this, you are going to apply the KVL. For this, I am starting from this point. Just try to understand. Wherever the resistance is there, I will write minus IR. Why? Because resistance is there, means potential drop should be there. So I am assuming potential drop is negative. That's why V is negative here. So V is equal to IR. So IR is negative here. And again, in the direction, if I am moving from low potential to the high potential, I am considering as positive, and from high potential to the low potential, I am considering as negative. See, we will see here. From this point, I am going to start. Here it will be minus 36I. Actually, it is I1, but we know I1 is equal to I2 is equal to, let it be I say, because both current, same current is flowing in both the loops. And across this resistor, no current will be there, so here it will be 0. Here I am moving from high to low. So here it will be minus E by 2, and here it will be minus IR1, and here it will be plus E. Why I am writing plus here? Why because I am moving from low to high. Minus to plus I am moving. That's why I wrote here this plus E, which is equal to 0. So after doing the calculations, we will get minus 36I plus E by 2 is equal to, minus IR1 is equal to 0. Minus 36I plus E by 2 minus IR1 is equal to 0. From this I will write E by 2 is equal to 36I plus IR1, and consider this is equation 1. E by 2 is equal to 36I plus IR1, and consider this is equation 1. Similarly, I will calculate for the loop 2. For loop 2, for apply KVL, we will write apply KVL for loop 2. We get, I am starting from here. In this direction, 39 is there. So minus 39I. Here again, try to understand. Resistance is there. So across the resistance, potential drop will be there. So potential drop I am considering as negative. So minus 39I. I am moving from low to high. So I will write it is E by 2. Again here the current will be 0. So potential is 0, which can be written as 0. From this I will write E by 2 is equal to 39I. I am considering this is 2. Second equation. And first equation, second equation we will consider. From that, what is asking the value of R1 is. We are going to calculate the value of R1. So we will see here. From 1 and 2. What is first equation? This is E by 2, This one also E by 2, and this one also E by 2. So we can equate 36I plus IR1 plus IR1 is equal to 39I. We can write IR1 is equal to 36 this side, so it is 3I. So R1 is equal to 3 ohms. This side cancel. So R1 is 3 ohms. So answer for this one is 3 ohms will be the answer. I hope you are understanding, right? See, try to understand. Even though it is advanced questions, see, while reading itself we will face difficulties while reading. Why? Because generally at the time of examination hall, students are in a lot of tension. When the students are in a lot of tension, they lost patience, so they will not read the question properly. But when we go through the question, even though it is advanced question only, but there is no extra topics. Clear what we studied generally. Here it is Wisdom Bridge, and we didn't apply any new concepts, right? By known concept only we solved. Clear? I hope you understand. Thank you.